Okay, so there's a couple ways to think about this. We could, if we really wanted to, arithmetize and pick numbers for x and y and then just use the calculator to compare them. The problem with arithmetizing when we have exponent questions is the numbers get weird, either because we have big numbers because of exponents, or the radical starts to mean we've got a lot of annoying decimals. And so either way, it's usually better to just know the rules. Now, there is a radical here. But the most important thing to remember about radicals is that they are exponents. And generally speaking, we want to convert everything to exponents. So the first thing I would do here is convert this to x to the third, y to the sixth, to the 1/3. Now, where is that coming from? Remember that a radical is kind of like a fractioned exponent. So the easiest thing is that the square root is x something to the 1/2, right? The square root 1/2, those things go together. So we're taking this number on the bottom, or inside, I should say, the radical, and that is the bottom of the fraction. So in this case then, now I am raising an exponent to an exponent. So this is another rule for exponents. So now what I'm going to do is I'm kind of going to distribute, but it's a complicated distribution. But basically I multiply. So I'm doing x to the 3/3 because 3 times 1/3 is 3/3, right? And then y to the 6/3. And that can be reduced because now we're just reducing fractions. 3/3 is 1, 6/3 is 2. So x to the first, y squared. And of course, we don't write the x to the first because we don't put ones on things, but there you go. So there are other ways to do it. You could think about this more in terms of reducing radicals, but in my experience teaching this stuff, I find that tends to lead to more mistakes. So, you should pick your poison basically, but you are going to need to understand this ability of radicals to become exponents that sometimes there will be no avoiding that. So really important that we know how to do that. Basically, remember, you can always just put it as the type of radical that we have is the denominator of the fraction. There are other shortcuts we could do with that, but in this case, I think it's better to just focus on turning that into an exponent and then dealing with other exponent rules. And when we raise a power to a power, an exponent to an exponent, that's when we multiply. And so that's what we did to get to this stage.